Hello class, this is Miss Riggins back at Starbucks and making a video on Super Bowl Sunday. Nonetheless, that's dedication, but nevertheless, today we're going to be talking about trapezoids and kites. We've been working with quadrilaterals and we're working with parallelograms, but there are some special quadrilaterals that are not parallelograms, and so we're going to look at those quadrilaterals, special quadrilaterals that are not parallelograms, which are trapezoids and kites. By definition, a parallelogram has two pairs of parallel sides, but a trapezoid only has one pair of parallel sides. And we call the pair of parallel sides the base. Oops, that doesn't that look pretty? So we call the parallel sides of a trapezoid the base. And we know it's parallel. This marking indicates parallel. The sides of the trapezoid that are not parallel are called the legs. Okay, and regular trapezoids are not as interesting as isosceles trapezoids. So we're going to take a look at the two different types of trapezoids. So here we have a trapezoid, and as you can see, there seems to be nothing special about the side lengths. In a regular trapezoid, so in a a non-isosceles trapezoid, we have that all the side lengths are different. And we have that all the angles are different. So in a non-isosceles trapezoid, all the side lengths are different and all the angles are different. But in an isosceles trapezoid, exactly two sides are congruent. And those two sides of the trapezoid are the legs of the trapezoid. So in an isosceles trapezoid, exactly two side lengths are congruent. No more, no less. And let's take a look at the angles. In an isosceles trapezoid, now instead of all the angles being different, we have two pairs of angles that are the same and two pairs of angles that are the same or congruent. So in an isosceles trapezoid, not only does it have exactly two sides of the same, but it actually has exactly two pairs of angles which are also congruent. So in this, we have a picture of an isosceles trapezoid. I know it's a trapezoid because it has exactly one pair of parallel angles, and it's isosceles because it has exactly two legs that are the same length. We call the angles that are made by a base and a leg the base angles. The base angles, and as you can see, the base angles are congruent in an isosceles trapezoid, whereas the regular angles in a regular trapezoid are not congruent, as we can see. So as you can see in this trapezoid, which is not an isosceles trapezoid, the side lengths are the congruent, and the angles, especially the base angles, are not congruent. So in a non-isosceles trapezoid, the side lengths and the base angles are not congruent. But let's take a look at the diagonals. In a non-isosceles trapezoid, not only are the side lengths not congruent, but also the diagonals are not congruent. And if we took a look at the angles of the diagonal, we can see those angles of the diagonals are also not congruent. So a regular trapezoid is kind of boring because it doesn't have any interesting properties. But in isosceles trapezoid, when we have two pairs of sides, only one pair of sides are congruent, and we only have one pair of angles that are congruent, one pair of sides that are parallel, we have two pairs of angles, base angles that are congruent in an isosceles trapezoid. And let's take a look at the diagonals. As you can see, the diagonals of an isosceles trapezoid are also congruent, but the angles aren't as interesting. So if I've been saying triangle, I apologize. I don't know why I'm saying triangle, but I should be saying trapezoid. So that's what this video is about. So this isosceles trapezoid has congruent legs, two pairs of congruent angles, and congruent diagonals. Now let's take a look at these congruent angles. Here is this angle. So here is this angle, here is this angle, here is this angle, and here is this angle. What do you notice? The pair of congruent angles are not opposite like they are in a parallelogram, but the pairs of congruent angles are adjacent. Same thing over here. This angle is congruent to this angle, but they are adjacent, not opposite. So an isosceles trapezoid has two pairs of congruent angles, and those angles are adjacent to one another, and we call them the base angles. Now let's take a look at a kite. Here's an example of a kite. It is a quadrilateral, but let's take a look at its side lengths. What do you notice about the side lengths? Oops, hold on, I found an error. Okay, sorry, I had to fix it. I had the same side length this measured twice. But anyway, here we have a kite, and a kite is a quadrilateral, and as you can see, it doesn't seem to have parallel sides. By definition, a kite is a quadrilateral that has two pairs of congruent sides, but instead of the congruent sides being opposite, the congruent sides are adjacent. So it has two pairs of congruent sides that are adjacent. Let's take a look at the angles. The angles of a kite has only one pair of congruent angles. So as I change this kite, the angles that are congruent are the opposite angles. So here we have this angle, angle GHE, and angle EFG. So a kite has two pair of adjacent congruent sides and only one pair of opposite congruent angles. And the way I remember, I know this is a kind of busy thing, but the congruent angles are opposite each other and they're in between two non-congruent sides. Now let's take a look at the diagonals of a kite and let me see what you notice. So let's take a look. Here's one diagonal, EG, and here's another diagonal, HE, of the kite. Uh-oh, hold on a second, that's not right either. HE. Oh. Sorry, I pulled the wrong length. The other diagonal is HF. So this diagonal and this diagonal, as you can see, the diagonals of a kite are not congruent, but let's take a look at their diagonal angles. And what do you notice? The diagonal angles are congruent. And not only are they congruent, but the diagonal angles are 90 degrees. So now we can add to it a statement that says not only does a kite has two pair of adjacent congruent sides and one pair of opposite congruent angles, and the diagonals are perpendicular and not congruent.